For more than a generation, Americans believed something very simple. When it came to advanced combat aircraft, the United States stood alone at the top. The skies were not just defended by American pilots, they were defined by American engineering. Stealth, speed, and dominance were not aspirations, they were expectations. And for a brief moment at the end of the Cold War, it seemed that no nation on earth could challenge that reality. That belief was not born from propaganda, it was earned. In the final decades of the 20th century, the United States Air Force faced a hard truth. Fourth-generation fighters like the F-15 Eagle and F-16 Fighting Falcon had proven themselves repeatedly, but advances in radar technology, surface-to-air missiles, and electronic warfare were beginning to erode their advantages. The next war, military planners feared, would not be won by speed or maneuverability alone. It would be decided by who could see first, strike first, and disappear before the enemy ever knew what happened. That realization gave birth to a revolutionary idea, a new class of aircraft that would not simply outperform its enemies, but evade them altogether. Thus began the quiet, expensive, and highly classified race toward what would later be called the fifth-generation fighter. In the early 1990s, with the Soviet Union collapsed and its once formidable air force in decline, the United States launched the Advanced Tactical Fighter program. The goal was ambitious and uncompromising. The new aircraft had to dominate the airspace of the future. It had to be stealthy enough to defeat modern radar, powerful enough to cruise at supersonic speeds without afterburners, and agile enough to win a dogfight if stealth ever failed. The result was the F-22 Raptor. When the F-22 entered service in 2005, it was unlike anything the world had ever seen. Its angular lines were not a stylistic choice but a necessity, designed to scatter radar waves and minimize detection. Its engines allowed it to fly faster than the speed of sound without the telltale glow of afterburners, a capability known as supercruise. Its avionics fused radar, electronic surveillance, and communications into a single picture that gave the pilot unprecedented situational awareness. To the public and to many defense analysts, the F-22 became the gold standard. It was not just a fighter, it was the embodiment of American technological supremacy. No rival aircraft could match it, and none appeared on the horizon. With fewer than 200 Raptors built, the United States seemed to possess a capability so advanced that numbers no longer mattered. And then came the F-35. Announced as the next great leap forward, the Joint Strike Fighter program promised something different. Where the F-22 was a pure air superiority machine, the F-35 was designed as a multi-role aircraft. One platform to serve the Air Force, Navy, and Marine Corps, replacing a wide range of aging fighters and attack jets. It would be stealthy, networked, and adaptable to nearly any mission. But expectations, shaped by the legend of the F-22, were unforgiving. As details emerged, critics focused on what the F-35 was not. Its stealth was optimized differently, and was not as extreme as the Raptors. Its ability to cruise supersonically was limited, and in some cases debated. Its maneuverability fell short of earlier air-to-air legends, and perhaps most visibly it lacked thrust vectoring nozzles, a feature many had come to associate with elite modern fighters. To some observers, especially those who remembered the clean dominance of earlier American designs, the F-35 felt like a compromise. What many failed to understand was that the F-35 was never meant to be another F-22. Its mission was not to dominate enemy fighters in isolation, but to act as a flying sensor, a battlefield coordinator, and a precision strike platform. It was designed for wars where information mattered as much as firepower, and where survival depended on remaining unseen in heavily defended airspace. Still, the debate over what truly defined a fifth-generation fighter had already spilled into the public consciousness. A set of informal, almost mythical standards had taken hold. Extreme stealth, supercruise, high maneuverability, and cutting-edge avionics, all in one airframe. Whether realistic or not, these expectations became the yardstick by which every future aircraft would be judged. And that is when the world began to change. While Americans argued over the merits of their own aircraft, other nations were watching closely. Russia, inheriting the legacy of Soviet aerospace engineering, pursued its own vision of a next-generation fighter. But it was another country, one rarely associated with original high-performance combat aircraft, that would truly challenge the old assumptions. China. For decades, China's Air Force had relied heavily on foreign designs, particularly those originating in the Soviet Union and later Russia. Indigenous development existed, but few outside observers believed it could rival Western or Russian achievements at the highest level. The idea that China might leap directly into the fifth generation was to many unthinkable. Yet history has a way of humbling certainties. As the 21st century advanced, it became increasingly clear that the era of uncontested American monopoly in advanced fighter design was coming to an end. Not because the United States had fallen behind, but because the world had caught up faster than anyone expected. The story of how that happened and how one aircraft would come to symbolize the shifting balance of aerospace power begins there, at a moment when fifth generation fighters stopped being an exclusively American concept and became a global reality. The end of American exclusivity in fifth generation fighter development did not come as a single dramatic announcement. It arrived quietly, through test flights, leaked photographs, and cautious official statements. And long before China revealed its ambitions, another familiar rival had already stepped back onto the stage: Russia. To understand why Russia could not ignore the fifth generation race, one must look beyond the post-Cold War years and back into the deeper history of military aviation. For most of the 20th century, the United States and the Soviet Union were not merely adversaries, they were technological mirrors. Each breakthrough on one side provoked a response on the other. Jet engines, radar, guided missiles, supersonic flight, none of these evolved in isolation. They were products of competition at the highest level. The collapse of the Soviet Union in 1991 appeared at first glance to end that rivalry. Funding evaporated, design bureaus struggled to survive, and entire aircraft programs were frozen or abandoned. But the engineering culture did not disappear. The experience, the knowledge, and the ambition remained, waiting for the moment when conditions would allow a return. That moment came in the early 2000s. As the United States fielded the F-22 and prepared the F-35 for service, Russian military planners faced a strategic dilemma. Fourth-generation fighters like the Su-27 and MiG-29 had once been equals, in some respects even superiors, to their American counterparts. But against stealth aircraft supported by advanced sensors and networked warfare, those advantages were fading. Russia's answer was a new aircraft known initially as the T-50, later designated the Su-57. Unlike the American approach, which had split fifth-generation roles between two aircraft, Russia pursued a single, versatile platform. The Su-57 was conceived as a multi-role fighter capable of achieving air superiority while also striking ground and naval targets. It reflected a different philosophy, one shaped by geography, budgetary realities, and a long-standing emphasis on maneuverability and raw performance. From the very beginning, comparisons to the F-22 were inevitable. In Western media, the Su-57 was often described as Russia's response to the Raptor. In some respects, that was true. Both aircraft sought reduced radar visibility, advanced avionics, internal weapons carriage, and supercruise capability. But the similarities ended there, where the F-22 prioritized stealth above all else. Russian designers accepted certain compromises. The Su-57 emphasized extreme agility, high speed, and aerodynamic efficiency, even if that meant a radar signature larger than that of its American counterpart. Thrust-vectoring nozzles, a hallmark of Russian fighter design, were included from the start, reinforcing the aircraft's focus on close-in combat and energy maneuverability. Predictably, criticism followed. Western analysts questioned whether the Su-57 could truly be considered a fifth-generation fighter. Its stealth characteristics were described as insufficient. The absence of a fully mature, purpose-built engine became a recurring point of concern. Even its avionics, long considered a weak spot in Russian aerospace development, were subjected to intense scrutiny. Yet those criticisms often ignored context. Developing a fifth-generation fighter is not simply an engineering challenge. It is an economic and industrial one. The United States spent decades and hundreds of billions of dollars building the infrastructure required to support such programs. Russia, emerging from years of economic instability, pursued a more gradual approach. Production numbers were limited. Testing moved slowly. Improvements were introduced incrementally rather than all at once. This cautious pace led some observers to dismiss the Su-57 entirely. Others, more familiar with the history of Russian aviation, took a different view. Sukhoi's design bureau had a long record of producing aircraft that matured over time. The Su-27 itself, once criticized in its early years, evolved into one of the most respected fighter families in the world. Variants like the Su-30, Su-35, and naval derivatives proved that initial skepticism did not always predict long-term effectiveness. In that light, the Su-57 was less a finished product and more a foundation. Still, even as Russia worked to reassert its presence, few in the West believed the global balance was truly shifting. The assumption remained that fifth-generation fighters were the domain of established aerospace superpowers, nations with decades of experience, deep industrial bases, and vast defense budgets. That belief would soon be challenged in a far more unsettling way, because while analysts debated whether Russia could match the F-22, a different country, one historically known for copying rather than creating, was preparing to leap directly into the most advanced tier of combat aviation. And when the first images appeared, they forced experts around the world to ask an uncomfortable question. What if the next major aerospace power was not following the old rules at all? For most of the modern aviation era, China was never part of this conversation. When Western analysts spoke about advanced combat aircraft, China was usually mentioned only in footnotes, as a customer, a licensed producer, or an imitator. Its Air Force flew capable machines, but few believed they reflected original design thinking. Instead, they were seen as echoes of Soviet and Russian concepts, assembled domestically and improved only incrementally. This perception was not entirely unfair, but it was dangerously incomplete. For decades after the founding of the People's Republic of China, the country's military aviation depended heavily on external assistance. In the early Cold War years, the Soviet Union supplied aircraft, engines, and technical expertise. When that relationship fractured, China continued to operate and reproduce existing designs, learning through necessity rather than innovation. Even into the early 21st century, the backbone of the Chinese Air Force consisted of aircraft derived from the Su-27 family, fighters that were formidable, but firmly rooted in fourth-generation thinking. By the numbers, the picture was clear. Hundreds of Chinese fighters were either purchased directly from Russia or built under license. The J-11 was essentially a Chinese-produced Su-27. The J-16 was a heavily modernized derivative of the Su-30. The naval J-15 traced its lineage to the Soviet Su-33. Even the indigenous J-10, often promoted as a fully original design, bore unmistakable signs of foreign influence, including conceptual similarities to Israel's cancelled Lavi fighter program and technical input from Russian specialists. To Western observers, this reinforced a comfortable narrative. China could refine, but not originate. It could manufacture, but not lead. That belief collapsed almost overnight. In late 2010, grainy photographs began circulating on Chinese internet forums. They showed a large angular aircraft parked on a runway near Chengdu Aircraft Corporation. At first, many dismissed the images as mock-ups or experimental demonstrators. The proportions looked unusual. The configuration defied expectations. Some analysts assumed it was a test bed or even deliberate misinformation. Then, in January 2011, the aircraft flew. The timing was impossible to ignore. Was the prototype lifted off, US Secretary of Defense Robert Gates was visiting Beijing, a coincidence that fueled speculation, unease, and more than a little embarrassment. Within days, the world knew the designation, J-20. Reactions ranged from disbelief to outright hostility. Veteran pilots, defense commentators, and aerospace journalists questioned the aircraft's legitimacy. Accusations came quickly. It was said to be a collage of stolen ideas. A nose borrowed from the F-22, intakes copied from the F-35, tail surfaces inspired by Russian prototypes. Some claimed it would never reach operational status. Others argued it would fly, but never fight. Yet, as the months turned into years, the tone began to change. Despite the secrecy surrounding the program, evidence accumulated. A second prototype flew, then a third. Flight testing expanded rather than stalled. The aircraft's size and configuration suggested a deliberate design choice rather than a technological dead end. Whatever the J-20 was, it was not a bluff. To understand how China reached this point, one must look at what came before. The J-10 program, initiated in the 1980s and brought to maturity decades later, marked a turning point. It forced China's aerospace industry to confront complex challenges: advanced aerodynamics, digital flight control systems, composite materials, and integrated avionics. Even if foreign assistance played a role, the program created something far more valuable than a single aircraft. It built institutional competence. By the early 2000s, Chinese engineers were no longer simply assembling aircraft. They were designing them, testing them, failing with them, and improving them. The J-20 was not a sudden leap from imitation to mastery. It was the result of a long, quiet accumulation of experience. Still, questions remained. Why build such a large fighter? Why adopt a canard configuration, something most Western designers had abandoned in the pursuit of stealth? Why emphasize internal weapon base and long-range engagement rather than close-in maneuverability? The answers pointed toward a strategic vision fundamentally different from that of the United States or Russia. China was not trying to replicate the F-22. It was not building a dogfighter for contested airspace over Europe. The J-20 appeared optimized for range, endurance, and interception, a platform designed to operate over vast distances, threaten high-value targets, and challenge air dominance at the operational level rather than the tactical one. As this realization spread, the conversation shifted again. The question was no longer whether China could build a fifth-generation fighter. It was whether the rest of the world had underestimated how quickly China could redefine what that generation meant. And with each new prototype, each confirmed squadron, and each carefully released image, one truth became harder to deny. The age of assuming technological superiority had quietly come to an end. As the J-20 continued to fly, a new debate began to dominate discussions in the West. It was no longer centered on whether the aircraft was real or whether it would enter service. Instead, the argument shifted to something more familiar and more dismissive: originality. Was the J-20 truly a new aircraft, or was it simply a sophisticated imitation? At first glance, the accusation seemed reasonable. Photographs revealed design elements that looked unmistakably familiar. The forward fuselage and canopy bore a resemblance to the F-22. The side-mounted air intakes echoed those of the F-35. The twin-engine layout and angular surfaces invited comparisons to Russian experimental aircraft, particularly the MiG-144, a prototype that had flown briefly at the end of the Soviet era. To many critics, the conclusion appeared obvious. China had taken proven concepts from American and Russian programs, blended them together, and produced a hybrid, impressive in appearance perhaps, but fundamentally unoriginal. Yet aviation history rarely rewards surface-level judgments. To understand whether the J-20 is a copy, one must look beyond its silhouette and examine the ideas behind it. Fighter design is not a matter of artistic creativity. It is an exercise in solving the same physical problems under similar constraints. Stealth aircraft by necessity begin to resemble one another. Radar waves behave the same way regardless of national borders, and low observability imposes strict geometric limits. Similar challenges often lead to similar solutions. The comparison to the MiG-144 is particularly revealing. Developed in the 1980s, the MiG-144 represented a Soviet vision of next-generation air combat, one that emphasized speed, altitude, and extreme maneuverability. Its canard delta configuration, large wing area, and closely spaced engines were optimized for high-energy flight, not stealth. Internal weapon bays were absent, and radar signature reduction was not a primary design goal. The J-20, despite superficial similarities, tells a different story. Its airframe reflects a fully integrated lifting body design, with smooth transitions between fuselage and wings, a hallmark of stealth-oriented aircraft. Weapons are carried internally, preserving a clean external profile. Panel alignment, edge treatment, and surface geometry all point toward radar signature management as a foundational requirement, rather than an afterthought. One of the most debated features of the J-20 is its canard configuration. Western designers largely abandon canards in stealth aircraft due to concerns about radar, reflections, and complexity. However, canards also offer significant aerodynamic benefits. When carefully integrated, they improve lift, reduce drag during certain flight regimes, and enhance control at high angles of attack. The presence of canards on the J-20 suggests a deliberate trade-off, accepting manageable stealth penalties in exchange for improved aerodynamic efficiency and range. Equally telling are the aircraft's air intakes. Unlike traditional variable geometry supersonic intakes, the J-20 uses diverterless supersonic inlets, or DSI intakes, a technology first tested on modified American F-16s in the 1990s and later adopted on the F-35. These intakes eliminate moving parts, reduce weight, lower maintenance demands, and improve radar stealth by eliminating boundary layer bleed slots. The cost of this choice is a reduction in maximum top speed, typically limiting aircraft to around Mach 2. This decision reveals much about the J-20's priorities. It was not designed to chase speed records. Instead, it was optimized for efficient supersonic cruise, reduced detectability, and long-range operations, characteristics consistent with interception and strike roles rather than close-in dogfighting. Even the aircraft's vertical tail configuration supports this interpretation. The outward canted, all-moving fins provide stability at supersonic speeds while minimizing radar reflections. Similar solutions appear in both American and Russian designs, not because they were copied, but because physics allows only so many viable options. When viewed as a whole, The J-20 does not read as a patchwork of borrowed parts. It reads as an aircraft shaped by global aerospace knowledge, filtered through China's specific strategic needs. This, in many ways, is the most unsettling conclusion for skeptics. If the J-20 were merely a copy, it could be dismissed. If it were a technological dead end, it could be ignored. But what the evidence increasingly suggests is something far more consequential. China did not simply imitate fifth-generation concepts. It absorbed them, adapted them, and built an aircraft optimized for its own vision of future warfare. And that realization set the stage for the final and most difficult question of all. How effective is the J-20 in the real world? And where does it fall short? By the time the J-20 began appearing regularly in official Chinese footage, the debate had moved beyond design philosophy. The final and most important question remained unanswered. What can this aircraft actually do, and where does the reality fall short of the promise? The pace of the J-20's development alone forced a re-evaluation of long-held assumptions. From its first flight in 2011 to operational service in the People's Liberation Army Air Force just a few years later, the program advanced at a speed few outside China had considered possible. Western fighter programs offered a stark contrast. The United States required nearly 7 years to move from the YF-22 prototype to the first production F-22, and another 7 years before the aircraft reached full operational capability. China compressed a comparable journey into roughly half the time. By 2016, production standard J-20s were entering service. By the early 2020s, estimates suggested that several dozen aircraft were already operational, with manufacturing capacity steadily increasing. While exact numbers remain classified, the trend was unmistakable. This was not an experimental curiosity or a symbolic program. It was becoming a real deployable combat system. Yet rapid progress often conceals unresolved problems, and in the case of the J-20, one weakness stands above all others: the engine. For most of its service life, the J-20 has relied on power plants that were never designed specifically for it. Early production aircraft were equipped with Russian-built AL-31 derivatives, engines originally developed for fourth-generation fighters. Later variants transitioned to China's domestically produced WS-10 engines, an important milestone for Chinese industry, but still not the final solution envisioned by the program's designers. Engine development has long been the most difficult frontier in aerospace engineering. While airframes and avionics can be improved incrementally, high-performance jet engines demand decades of refinement, advanced materials, and manufacturing precision. The United States, Europe, and Russia reached this level only after generations of trial and failure. China entered this arena far later, and the gap has been difficult to close. The long-awaited answer to this challenge is the WS-15 engine. On paper, its specifications are ambitious. With an estimated thrust of 16 to 18 tons and significantly improved non-afterburning performance, the WS-15 is intended to give the J-20 true supercruise capability, sustained supersonic flight without the fuel penalty and infrared signature of afterburners. If fully realized, this would elevate the aircraft into the same operational class as the F-22. As of the mid-2020s, testing continues. Progress has been reported, but definitive public confirmation remains scarce. Until the WS-15 enters widespread service, the J-20's performance envelope remains constrained, particularly in sustained high-speed flight. Firepower, however, is not where the J-20 appears to compromise. The aircraft features 3 internal weapon bays, a large central bay, and 2 smaller lateral bays. This configuration allows it to carry its primary armament, while preserving low observability. The main bay is designed to house beyond visual range air-to-air missiles, such as the PL-12 and the more advanced PL-15, both equipped with active radar seekers. The PL-15, in particular, is widely regarded as a long-range missile intended to challenge Western air dominance at extended distances. For close-range engagements, the J-20 employs the PL-10 infrared guided missile, a highly maneuverable weapon comparable to the latest Western short-range air-to-air missiles. The lateral bays feature a clever launch mechanism that ejects the missile into the airflow before ignition, allowing the bay doors to close rapidly and reducing aerodynamic and radar penalties during high-G maneuvers. Notably absent is an internal cannon. This omission speaks volumes about how the aircraft is intended to fight. The J-20 is not optimized for traditional dogfighting. Its designers appear to have prioritized long-range detection, missile engagement, and coordinated operations over close-in aerial combat. Avionics and sensors remain the most opaque aspect of the program, but what is known suggests a high level of sophistication. The J-20 is equipped with an active electronically scanned array radar, supplemented by additional side-looking arrays that expand situational awareness. An electro-optical distributed aperture system provides all-around surveillance, tracking aircraft, ground targets, and missile launches while enabling a night, and low visibility operations. An electro-optical targeting system mounted in the nose supports precision engagement and identification. Taken together, these systems indicate a design philosophy similar to that of the F-35, emphasizing sensor fusion, information dominance, and networked warfare. If performance approaches Western benchmarks, the J-20 would represent not just a stealth aircraft, but a fully integrated combat platform. Still, questions persist. Can the J-20 maintain low observability with its canard configuration? Does it achieve true supercruise with current engines, or only limited supersonic flight under specific conditions? How effective are its stealth coatings over time and in operational environments? And perhaps most importantly, how well does it integrate into broader command and control networks during real combat operations? China has offered few answers. Much of the available data remains classified, and public demonstrations are carefully curated. Lundberg lenses are often installed during exercises, deliberately masking the aircraft's true radar signature. This secrecy fuels skepticism, but it also reflects confidence. Nations rarely conceal capabilities they do not possess. What can be said with certainty is this: the J-20 was never intended to mirror American or Russian fighters. It was designed to serve China's strategic needs, to patrol vast airspaces, to threaten high-value assets, and to complicate any adversary's planning long before shots are fired. After just a decade of operational experience, the J-20 has evolved from a controversial prototype into a cornerstone of China's air power. Its strengths are real, its weaknesses are narrowing, and its very existence signals a profound shift in the global balance of aerospace capability. For the first time since the dawn of the jet age, the future of air combat is no longer shaped by one nation or even two. It is being defined by a new multipolar reality, one where assumptions of technological superiority can no longer be taken for granted, and where the skies, once dominated by familiar names, are becoming far more crowded and far more contested.